Hey everyone, good morning and welcome back again. We are live, and today in the bridge course for NEET 2026 preparation, we are going to take the last interaction for relative motion. So today we will majorly emphasize on a rain umbrella problem, but apart from that, we will be talking about the ship models, distance of closest approach, flag fluttering model, other relative velocity or relative motion based models we are going to get familiar with today. Okay, so the thing is that if you remember, we have started together this topic of relative motion in the last session. Then in the last session we talked about an important model related to the relative velocity or relative motion, that is a riverboat problem. And today we are going to handle rain umbrella and few other models. So for any of the new learners who have just joined, or this is the first time for learning from this session, then definitely I would suggest you to spare out some time to figure out some time, and you spend that time with riverboat and relative motion also, because definitely from the relative motion topic we can expect one direct problem in the final NEET exam. All right. So although this is a bridge course, a fundamental course that boosts up your basics, that will make you familiar with more and more variety of models that you can expect in the NEET exam for our NEET 2026 exam. But definitely at the same time, you must remember my words. I always keep on saying that whatever things you are learning in this bridge course are not restricted to the particular unit, but that will be repeated in almost every other topic and chapter of physics. All right, so this is the starting of mechanics with me. Let us start the discussion today with the rain umbrella problem, that is from relative motion. All right, now, so first of all, I'll introduce the concept for you. What is rain umbrella model based on? What is the concept exactly? Let's try to feel it. That suppose I am an observer standing on the ground and the rain is falling vertical. If the rain is falling vertical, then in order to protect myself from rain, in order to prevent from getting, if I want to, I don't want the raindrops to hit me. So what I'll do, I'll hold an umbrella. So if the raindrops are falling like this and I am standing, then I should hold the umbrella like this, vertically, like this. But if in the same vertical rain, I'll start walking like this, then definitely the raindrops which were supposed to fall down, they are still falling down. But because of for an observer who is walking or running, or you would have experienced this, that suddenly rain has started falling and raindrops are vertically falling down, but you are on a scooter or a scooty, or you are on a bike, so you feel that the raindrops are hitting on your face like thorns, very sharp hitting. So why is that happening? That is based on relative velocity. But as of now, talking about the same situation, raindrops are falling vertically, but you are walking like this. So same raindrops will appear to be, hitting you in an inclined direction. So in order to protect yourself from the same raindrops, you should not be holding the umbrella vertical. You should be holding the umbrella like this. So what I'm trying to conclude is that in the rain umbrella problem, the actual velocity of rain is not something which we are focusing on. The velocity of observer or man is also not that on which we are focusing on. What we are interested in is finding the velocity of rain with respect to man, with respect to observer. According to me as an observer, if rain will appear to be falling from here, then I will hold the umbrella like this. If according to me as an observer, rain will appear to be falling like this vertically, then I'll be holding the umbrella like this vertically. And if the raindrops are appearing to be falling from this direction for me, relative to me, then I'll be holding the umbrella like in this direction. Isn't it very simple? So what we are interested in is the velocity of rain according to man or relative to man. I hope the situation is clear. So in this concept, what we can see here is, first of all, step one, I'll be talking about the steps. Okay. So step one, some steps to be taken. Step one, I'll try to write the velocity of rain with respect to ground. This is the actual velocity of rain. Velocity of rain with respect to ground. I'll be writing it. I may represent it diagrammatically. I may represent it in terms of I cap, j cap, k cap, like that. Your choice. The same problems today can be solved diagrammatically. The same problems today can be solved on the basis of I cap, j cap and k cap. Step 2. Step 2. I will be writing velocity of man with respect to ground. Man or observer or a girl in any situation, anything can be there. So you have to write this, either represent it diagrammatically or you will be writing it in terms of I cap, j cap, k cap. Writing in terms of I cap, j cap, k cap, like I'll tell you, these are the directions on the ground: east, west, north, south. This is up and this is down. All right. So if you have to designate the direction, unit vectors in these directions, east can be written as I cap, west can be written as minus I cap, up can be written as j cap, down can be written as minus j cap, north can be written as minus k cap, and south can be written as k cap. I hope you are good with it. What I am doing is I am dedicating the unit vectors to different directions, and your ground is basically your east, west, north, south, means xz plane. This xz plane, if you imagine, this xz plane is basically serving as a ground, x-axis and z-axis. This xz plane is ground. Okay, so east, west, north, south are directions on the ground. East, west, north, south are directions on the ground. Perpendicular will be up and perpendicular will be down. Perpendicular will be up here and perpendicular will be down. Okay, so with the x-axis, with the y-axis, like that. So again, coming to the steps, you are looking for velocity of rain with respect to ground, then you are looking for velocity of man with respect to ground, either diagrammatically or in terms of I cap, j cap, k cap here. Okay, now step 3, you are finally looking for, step 3 is the most important step, you are finally looking for velocity of rain according to man. Velocity of rain according to man. First one is the object, second one is the observer. So velocity of rain with respect to man, by formula, that can be written as velocity of rain with respect to ground, velocity of rain with respect to ground, which you have already written over here, minus velocity of man with respect to ground. So these two are already written or portrayed diagrammatically in step 1 and step 2. Then you have to do the vector subtraction, or you can also say that vector subtraction is nothing but negative addition. Subtraction is nothing but negative addition, which means you may have to write the two vectors and add them. One of the vector is velocity of rain with respect to ground, plus another vector is minus of Vm with respect to ground. Okay, this can also be written like this. Okay, and say that comes out to be Vx I cap plus Vy j cap. Suppose that comes out to be Vx I cap plus Vy j cap, means we will be writing step 1, step 2, we will do the vector subtraction, and after doing all this you will get something as your answer. No, now let us suppose that something which is your answer is in front of you, that is written as Vx I cap plus Vy j cap. Suppose it will come in every problem, but suppose it comes like this. Then there are two questions which examiner can ask you here. Question number 1, examiner might ask you that speed with which raindrops hit the man. Speed with which raindrops hit the man. What is that speed? How to get that? So I will say you have already got a relative velocity vector. So if you are needing the relative speed, then you got relative velocity, take its magnitude. Everyone knows that instantaneous velocity's magnitude will be the instantaneous speed. So here at that moment, if the relative velocity at that instant, if the relative velocity is this, then you have to take its magnitude. Velocity of rain with respect to man, that's a vector. Take its magnitude, you will get the speed with which the raindrops will hit the man. And if suppose you got it as Vx I cap plus Vy j cap, then how to get its magnitude? Its magnitude will be under root of Vx square plus Vy square. Vx square plus Vy square. I hope that's easy. And the second question that is attached here is that how to hold the umbrella. Like as I said, that we are interested in looking for the velocity of rain with respect to the man. So according to me, if the raindrop is coming like this, I'm supposed to hold the umbrella like this, making some angle with the vertical or making some angle with the horizontal x-axis. So I will say that here, how to hold the umbrella. How to hold the umbrella. So how to hold the umbrella? You have two things here. First of all, they might ask angle with horizontal. So if they are asking you angle with horizontal, phi with horizontal or phi x, phi with horizontal or phi x axis, then it is always tan inverse. Remember the vector rule? With whichever axis the angle is made, that component must be coming in denominator. With whichever axis angle is made, that component must be coming in denominator. So that is tan inverse. If you are making the angle with x-axis, then it is Vy by Vx. Vy and Vx are the x and y components here of the relative velocity, not the individual velocity. And similarly, if they are asking you angle with the vertical or phi y, with whichever axis the angle is made, that component must be coming in denominator. So that will be tan inverse Vx by Vy. Tan inverse Vx by Vy. I hope that's clear for us. Understood. So that is the theme of rain umbrella problem. In every question now, we will be keep learning about like how to implement these concepts. A quick recap of the concept. The point is the theme of this rain umbrella problem is the rain falls in a certain way, maybe vertical, maybe inclined. You as an observer, till the time you are standing, you will observe the actual velocity of the rain. But suppose you yourself as an observer is also has started walking or running or driving in the rain. Then in that case, what you are interested in is not the actual velocity of the rain, not your actual velocity, but what you are going to deal with is the relative velocity. What relative velocity, sir? Velocity of rain according to the man. So velocity of rain with respect to man. Once you got that vector by vector subtraction, if you can't subtract, then do the negative addition. Okay, but you will get some resultant vector having some horizontal component, having some vertical component. So if you are interested in the first question, the speed with which raindrops hit the man, then that will be under root of V horizontal square plus V vertical square, normal vector taking the magnitude of a vector. And then how to hold the umbrella if they are asking you the angle. So if the angle is made with horizontal, then the horizontal component or x component must be coming in denominator. If the angle is made with vertical, then the vertical component or y component must be coming in the denominator. And if you want to do the same question, not mathematically, but diagrammatically, then diagrammatically you can dedicate these unit vectors along the x-axis, y-axis and z-axis. I hope that's clear. Yeah, good morning, Rohini. Yeah. Any doubt to anyone? Any of the learners? Do you have any doubt or can we start with the problems? So today majorly we are going to deal with the rain umbrella problem, but apart from that we will also look for other relative velocity models. And today we will put a full stop on the crucial topics of kinematics. So these were the 10 sessions throughout in which we have learned a lot of fundamentals, and our next interaction will be from the topics of laws of motion, conservation of momentum and all. So make sure you attend the all the sessions because they will be benefiting you a lot. And these are the topics which I am deliberately taking in such a way where so that the students, these are the topics in which majority of students either have a doubt or they do the silly mistake, or else these are the topics which are going to get repeated in many different chapters of physics. Okay. So these are the few reasons, keeping in mind, I select the topic for you and then we are meeting on regular basis. Okay, so I think there is no further doubts here. Keep it in mind what to do stepwise. We'll practice them. So the first problem is in front of us. A man sitting in a bus traveling in a direction from west to east with a speed of 40 km per hour observes that the raindrops are falling vertically down. Observes, which means that is the relative velocity. Man himself is moving because he is sitting in a bus, and he observes that, means it is a relative velocity. To the another man standing on the ground, the rain will appear. To the another man standing on the ground, the rain will appear. Then you need to keep it in mind that velocity of rain with respect to man will be given by velocity of rain with respect to ground minus velocity of man with respect to ground. Okay, velocity of man with respect to ground. So they are giving you this velocity of rain with respect to man, but they are asking you the actual velocity of rain with respect to ground, because they are saying that what will be the velocity of the rain to a man standing on the ground. So to a man standing on the ground, if I'm standing on the ground, not moving anywhere, what I will observe? The actual thing. And if I myself am moving, then what I'll observe? The relative thing. Make sense? So they are giving you the relative thing here and they are asking you this. So what I can write here is velocity of rain with respect to ground. I'll just rearrange them. So that will be velocity of rain with respect to man plus velocity of man with respect to ground. It's like effective velocity. Effective velocity, A on B, B on C will give you A on C. Okay. Rain on man, man on ground will give you rain on ground. Anyways, so the first statement was kind of relative velocity statement. When you rearrange, just taking the term on the other side, that became positive. We got something called effective velocity. But yeah, we can proceed like this. So suppose I want to write that in terms of I cap, j cap, k cap. Suppose I want to write it in terms of I cap, j cap, k cap. So way 1, a man sitting in a bus traveling from west to east. So the bus is moving from west to east. For your convenience, let me draw this again for you. This is east, west, north, south, up and down. All right. So here we have seen that the bus is moving from west to east. So this is the man with respect to ground, or bus with respect to ground is something like this. Velocity of man with respect to ground. All right. This is in this direction, west to east. We know that we can take it as I cap. And the other one is raindrops are falling vertically down. Raindrops are falling, observes that raindrops are falling vertically down. If he observes, means that is the relative velocity. That is the relative velocity. That is, you will say velocity of rain with respect to man. Velocity of rain with respect to man, vector. So I will draw this as it is down, right? Let me represent everything from the origin. Okay. And this is velocity of rain with respect to man. Fine. And we need to find its resultant. We need to find its vector resultant. So diagrammatically, can you say that, see, this is one of the vectors, this is another vector, and I'm not writing its magnitude as 40 in the problem, although they have given. But why then you are not considering it, sir? Because no options are talking about a data. Every option is talking about a certain direction. So if we are anyways interested in the direction, and anyways the relative velocity's direction is given, falling vertically down, but its magnitude is not mentioned. So I'm going to take its resultant, say by parallelogram law. I'll complete the parallelogram. I've completed the parallelogram. Okay. And I'll take its resultant. So its resultant is something like this. So can I say, so it's an angle made in the eastern direction. So it's down only, but it is towards east, making a certain angle. This angle phi is made with vertical. This angle phi is made with vertical towards east. made with vertical towards east, like that. So see, diagrammatically you could directly got it. You could directly get it. So what is that exactly? Up, down, east, west, north, south I have drawn. The bus, once more, the bus and the man sitting in the bus both are moving from west to east. If they are moving from west to east, this is the direction of velocity of man with respect to ground. And he observes that the raindrops are falling vertically down. So the relative velocity of rain with respect to man, the relative velocity of rain with respect to man is vertically down. By rearranging, you understood that you are going to vectorially add them up. Then only you will get the actual velocity of rain with respect to ground or with respect to a stationary person. So when we completed the parallelogram, our resulted in this somewhat like this. So this angle is made with vertically downward direction, but towards which direction? It is made towards east. So which option should be correct over here? So you will say to fall vertically down, to fall an angle going from west to east, to fall at an angle going from west to east, like this. And okay, I think that's cool for us. Did you understand? Tell me in the live chat section if you have any doubts. I didn't use any of the formula over here. Why you didn't use any formula, sir? Here you said that there are two methods, either diagrammatically or do it by the formula. I didn't use any of the formula here because the two numerical values are not given to you. Only one value is given. In the three vectors, at least two of them will be given to you and third one will be required. Then only you can solve it numerically, no. But here what is happening, that one, like I would say that here only one of the data are given. So any third data you can't find out. If an equation contains three things, then two should be given and third should be required. But here you can see only one is given. And interestingly, in all the four options, not even the third one's magnitude is required. Only direction they were dealing with. So if they are dealing with the direction, diagrammatic approach is a better approach. Is that clear? So let's see some more models. You will be more familiar. Another question is, okay, so I think in a hope I have taken this, that yeah, it is already right. Rain is falling vertically downwards with a speed of 4 km per hour. Now rain is falling vertically downwards with a speed of 4 km per hour. So I'm writing it again and again. Velocity of rain with respect to ground. Velocity of rain with respect to ground, that is 4 km per hour and it is vertically downwards. If it is vertically downwards, I can write it as minus j cap. And then they are saying a girl moves on a straight road with a velocity of 3 km per hour. So velocity of girl on the ground is 3 km per hour in I cap. Suppose they didn't say that where the girl is moving. They didn't say where the girl is moving. So I have taken it that let us say she's moving in the I cap, means towards east, The apparent velocity. What do you mean by apparent velocity? Apparent means observed or relative here. They are asking you the relative velocity of rain with respect to the girl, and see they are asking you only magnitude. In the previous question they asked only direction. In this question they are asking only magnitude. So way one of doing it, relative they are asking. So they are asking velocity of rain with respect to girl. So that will be given by velocity of rain with respect to ground minus, see relative is always given by minus, velocity of girl with respect to ground. Alright, velocity of rain with respect to ground minus velocity of girl with respect to ground. So velocity of rain with respect to ground is 4 minus j cap and minus it is 3 into I cap. So what I am getting is minus 3 I cap, just rearranging it, minus 3 I cap minus 4 j cap. So if they are asking you the speed, since all the four options were magnitude, so velocity of rain with respect to girl, if I take the magnitude, so that will be under root of minus 3 square plus minus 4 square. That's how you take the magnitude of a vector here. And ultimately 3 and 4, Pythagorean triplet, 3, 4 and 5. And hence the answer will be 5 km per hour. 5 km per hour. So this is one way, see, I have done it diagrammatically, representing it in terms of I cap, j cap, k cap, where again its direction was not given, so I have assumed it, I have supposed it. Okay. Now, way two, let's say diagrammatically I want to do it. So rain is falling vertically downwards. So rain is falling vertically downwards. This is V of rain with respect to ground. V of rain with respect to ground, and that is equal to 4. All right. And then there is velocity of girl with respect to ground, and that was given on in horizontal. That was not given east, west, north, south. So suppose that I have taken it like this, and that is equal to 3. Okay. They are asking you the apparent velocity. So what you need to understand is again the same, that in order to talk about the apparent velocity or relative velocity, formula is velocity of rain with the apparent velocity of rain with respect to girl. So velocity of rain with respect to girl will be given by velocity of rain with respect to ground minus velocity of girl with respect to ground. And diagrammatically, if we are not interested in vector subtraction, then always remember that subtraction is nothing but addition, negative addition. So there are two vectors, velocity of rain with respect to ground plus minus of velocity of girl with respect to ground. All right. So basically, what I am telling is, just a moment. Yeah. So basically what I am telling is, you have represented the two vectors and you have to add them. But which two vectors, sir? One vector is velocity of rain with respect to ground. That's already in front of you. Another vector is minus of velocity of girl with respect to ground. But what we have represented here is velocity of girl with respect to ground. No issues. Now I'll represent its minus. So this is minus of velocity of girl with respect to ground. Putting a minus sign in front of a vector only reverts its direction. Keeping a minus sign in front of a vector only reverts its direction. It doesn't contribute in magnitude, and hence its magnitude is again going to be equal to 3. Okay. So one is 3 horizontal, one is 4, one is 3 horizontal, one is 4 vertical. Definitely if you are going to, let me draw 3 smaller than the 4. If you are going to complete it, here by parallelogram law, okay, you are actually doing vector subtraction, but you are doing subtraction by taking it as negative addition, because this triangle law, parallelogram law, these are not the laws of vector subtraction. These are all the laws of vector addition. So when you are going to add it, directly use parallelogram law. When you are going to subtract it, first of all, convert the subtraction into negative addition, which means one vector should be directly taken as it is, another vector's negative should be taken, means in opposite direction. And then you apply the parallelogram law, and here you will get the velocity of rain with respect to girl, and that will be given by under root of 3 square plus 4 square, and hence that is going to be equal to 5. 3, 4 and 5 are Pythagorean triplet. I hope that's clear to you. Is that okay? Let me change the color here so that it will be much clearly observed to you. Now see. Is that clear? Yes. Hi, good morning. Yes. So that is another one. So in the previous question, we have seen, like, first of all, I gave you a quick recap. I gave you the concept what to do. Then we have taken the recap. The steps are velocity of rain with respect to ground, velocity of man with respect to ground, then velocity of rain with respect to man or girl or an observer, whatever it is. Then that is given by vector subtraction. If you are going to do it diagrammatically, remember that subtraction is nothing but negative addition. So you have converted it into negative addition, then you can use triangle law, parallelogram law. For our discussion, we are every time going to use the parallelogram law of vector addition. Since we have to subtract, we will convert it first of all into negative addition. Okay. Once we get the final vector, its magnitude will answer the first question, speed with which the raindrops hit the man. How to hold the umbrella? Its direction basically. And the rule is again the same. If you are interested in finding the angle with the horizontal x-axis, then that will be tan inverse Vy by Vx. Y-axis tan inverse Vx by Vy. The rule is with whichever axis the angle is made, that component must be coming in denominator. Then we have discussed today one problem in which they were only strictly talking about the direction with no involvement of magnitude. So diagrammatic approach is a better approach. Then we are talking about the magnitude. So for calculating the magnitude or in general to answer both the questions, generally we have two methods of dealing with it. Method one, we can deal with I cap, j cap, k cap, keeping the vector convention, ground and everything in mind. Method 2, we can still solve it diagrammatically. So if it comes in the final NEET exam, obviously you have to stick with any one of the methods. But for few problems, I may be discussing both the methods with you. And if you are dealing with direction only, then strictly diagrammatic approach is a better approach for us. Okay. Yeah. Motion in a plane, completed chapter. No, here we are not completing the chapters. Chapter completion and everything will be done, in the proper regular program in the offline batches. Here in this bridge course, it's a bridge course, dear. So in this bridge course, we are actually emphasizing on the crucial topics, sometimes on the fundamentals, sometimes on the difficult things, sometimes on the things which are going to get repeated in various chapters and topics. All right. So there are proper reasons because of which we think that these are the topics which will boost up your score in the final exam. That's why we are going to discuss only those topics first. Okay. Chaliye, next problem. A man standing on a road has to hold his umbrella at 30 degree with the vertical. See, a man is standing on the road. If the man is standing on the road, which means it is the actual velocity of rain, the rain is falling 30 degrees with the vertical to keep the rain is falling 30 degrees with the vertical. That's why the man has to hold the umbrella 30 degree with the vertical. Let me draw the situation for you. So there is this man. This man is standing, okay, at rest. And he has to hold his umbrella 30 degrees with the vertical. 30 degrees with the vertical. The man has to hold his umbrella to protect himself from the rain. Okay. Then this implies definitely the rain will be falling like this. 30 degrees with the vertical. The rain will be falling like this. How you are sure it is 30 degrees, sir? See, diagrammatically, these are alternate interior angles. So this is velocity of rain with respect to ground. Velocity of rain with respect to ground vector, that is making an angle 30 degree with the vertical moving down. He throws the umbrella and starts running at 10 km per hour. He throws the umbrella and starts running at 10 km per hour. He finds that the raindrops are hitting his head vertically, which means now I will say in the second situation, the person starts running with a speed of 30 km per hour, 10 km per hour. So how to move it? So how the man should be moving? Suppose, so I'm going to break this into two components. This will be VRG in the Y direction and this will be VRG in the X direction. So I can also say that vertically it is VRG, since the angle is made with vertical, it is cos 30 degrees and it is VRG sin 30 degrees. All right. Now the man, suppose the man is moving in this direction. Second situation, the man is moving in this direction, VMG. So if I see here, there will be minus VMG. You remember now that the vector in which you are interested is not VMG vector. The vector in which you are interested is the minus VMG vector. And at 10 km per hour. 10 km per hour. So definitely here also it is going to be 10 km per hour. Why you are saying that, sir? Because putting a minus sign is, again I would say the same thing, putting a minus sign will only revert the direction. Putting the minus sign will only revert the direction. I hope that is clear with you, that why I'm searching for minus, because I'm always interested in actual velocity of rain and negative of velocity of observer. Actual velocity of rain I have already shown. Velocity of observer is like this. I'm trying to take the negative of velocity of observer. Negative of velocity of observer, that is there in front of you. Now, so you will say this is already VRG cos 30 degrees and this is VRG sine 30 degrees. VRG sine 30 degrees. What they are saying is that the rain appears to fall vertical. For this one, for moving man, raindrops, he finds that the raindrops are hitting his head vertically. Raindrops are falling vertically for the moving man. Okay, that is, can I say horizontal components must be balanced? Horizontal component of velocity, horizontal components must be balanced. Okay, so if I balance the horizontal components, so can I say this must be equal to this, must be same? That is, I would say here that VRG sine 30 degrees, which is basically 1 by 2, that is equal to VMG and that is equal to 10. Okay, that is equal to 10. So let me write it in the next step. So VRG sine 30 degrees is 1 by 2. VMG's magnitude, that is equal to 10 over here. So from here, VRG equals to 20. From here, VRG is equal to 20 km per hour. And hence your correct option is 20 km per hour. I hope the situation is clear to you. Once again, what to do, sir? Follow the same steps. First step is velocity of rain with respect to ground, either diagrammatically or you do it in terms of I cap, J cap, K cap. Second step, velocity of man with respect to ground. Third step, the relative velocity, which is given by subtraction. But diagrammatically, we all are happy with addition. So subtraction must be converted into negative addition. All right. See, I have done the same. I have read the question. The first line of the problem is giving me the hint of velocity of rain with respect to ground. The second line of the problem is giving me the idea for velocity of man with respect to ground. But I am interested in negative of the vector, minus of VMG. Then I have talked about the relative velocity. According to this, the relative velocity is vertical. So horizontal components must be balanced. Okay, so I have just balanced them, equating them. I have got the final answer. Any doubts? No doubts? Hope we are done with this. Okay, we'll keep discussing more and more. Don't worry. Here, there might be a doubt. There might be a doubt that students have. I'm just, keeping it here because I am standing in front of you to tell you that, how to do it. But suppose there is a common doubt I'm going to talk about, common mistake in this problem. The common mistake in this problem is examiner didn't say that where the observer started running. You have taken it that the observer is running or the man is running in this direction. What if the man is running in this direction, sir? What if the man is running in this direction and in the towards right or towards east? So I'm going to represent it. See here, this is velocity, like this is VRG cos 30 degrees. This is VRG sine 30 degrees. Okay. Suppose the man is running in this direction. Suppose the man is running in this direction, VMG, then definitely there will be a minus VMG like this. Minus VMG like this. So it will get bigger, right? Instead of this VRG sine 30, let me draw it here. Okay. Now understand it this way, that VRG cos 30 degrees component is downwards. VRG sine 30 degree component is leftwards or towards west. Suppose if the man is moving like this in this direction, suppose if the man is moving like this in this direction, then definitely this component will increase. If this component will increase, then instead of making 30 degrees, it will be making much bigger angle with the vertical. So its resultant will be somewhere here. Its resultant will be somewhere here, and the earlier angle was 30 degrees, but this angle phi or this angle theta will be greater than 30 degrees because this component has increased. So vector resultant will turn towards x-axis. I hope that's clear, which means this is not possible. This is not a possible case here in this situation. Why not it is possible, sir? Because you needed the final answer in vertical direction. Here the final answer will be in this direction. This will be velocity of rain with respect to man, which is not required. This is the velocity of rain with respect to man, which is not required. The actual velocity of rain with respect to man, it was required vertical. Actual velocity of rain with respect to man is required to hit his head vertical. Okay, so there were two choices always. The man could have moved like this, the man could have moved like this, both the direction. If man moved towards right, the minus VMG component increases the horizontal one, so the angle will be much more towards horizontal. And if the man is moving towards west, then minus VMG will be towards east. That will compensate the rain's horizontal component, and what you are left with is only vertical component. Okay, so sitting in the NEET exam, if you are dealing with such kind of problems and this thought comes in your head, then definitely you can answer it easily. But sometimes as a student, you may start with this situation. So I didn't want to skip the situation. I want you to understand that even if you start with this situation, you should realize that this is not the result which is required. So that's a common mistake. Students sometimes, waste a lot of thought and energy and obviously the time while getting stuck in this. So there were two possibilities. Make sure you remember them. Okay, G, is that clear? All right, let's move on to the next one. Yes. Rain is falling vertically with a velocity of 25 meter per second. It is already given that rain is falling vertically 25 meter per second. So I'll just represent it diagrammatically. This is velocity of rain with respect to ground, and that is 25 meter per second. Take care of the units also. A woman rides a bicycle with a speed of 10 meter per second in the north to south direction. I hope you remember this, that this is east, west, north, south, up and down. All right. So north to south direction means this with a speed of 10 meter per second. With a speed of 10 meter per second. So this is velocity of woman with respect to ground. Velocity of woman with respect to ground, and that is 10 meter per second. 10 meter per second. In the north to south direction, see what is the direction angle with the vertical in which she should hold the umbrella to save herself from rain. To save herself from rain, I'm just zooming in this figure, and I want you to understand that you are interested in VRG, but you are not interested in VWG. What you are interested in is minus of VWG. है ना? You are interested in is minus of VWG. So this is VWG for you. Let me draw minus VWG. I'm drawing it like this with a solid line here. This will be minus of VWG. Okay, and negative will only change the negative will only change the direction. There will be no change in the magnitude. Like this we got. Okay, the convention I'm just mentioning it here. All right, now, so that is the situation. We are interested in, see what they are asking, in which direction she should hold the umbrella. So I'm trying to write velocity of rain with respect to woman. So that will be given by velocity of rain with respect to ground. Okay, minus velocity of woman with respect to ground. All right. And diagrammatically, we are always interested in vector addition. So this is VRG. Subtraction is nothing but negative addition, minus of VWG. So VRG vector is in front of you, minus VWG is there, and you are supposed to take its resultant. So if you are supposed to take its resultant like this, so this is going to be the resultant. This is velocity of rain with respect to woman. If they are asking you the magnitude, the speed with which the raindrops will hit the woman if there is no umbrella, then that can be written as under root of 10 ka square plus 25 ka square. 10 ka square plus 25 ka square, whatever it is, although they didn't ask. What they asked is angle with the vertical. They are asking you the angle with the vertical. They are asking you this angle, 5e. Okay, so here 5e will be equal to, I hope you remember that tan inverse, the rule is very simple. If the angle is made with whichever axis, that component must be coming in denominator. So tan inverse, it should be V horizontal by V vertical. If the angle is made with vertical, the vertical component must be coming in denominator. If the angle is made with vertical, see, vertical component, the green colored, must be coming in denominator. So that is tan inverse. And horizontal component is that 10, because east, west, north, south, all are the directions on the ground horizontally. That is 10 by 25. 10 by 25 is basically, or tan inverse 0.4. The moment you will keep a decimal, this 10 will become 100. 100 by 25 is 4. So tan inverse 0.4, that is the correct option. I hope that's clear to us. Just have a look. What did I do? Again, I have done the same. Again, I have followed the same steps here. Velocity of rain with respect to ground, then velocity of man with respect to ground, then minus of velocity of man, or here woman, with respect to ground, and then I have taken the relative velocity, the magnitude of which will give you the speed by which the raindrops will hit the person or the observer, and the direction angle is made with vertical, so vertical component will be taken in the denominator. If they ask the angle with horizontal, the horizontal component must be kept in the denominator. All right, let's go. Let's move on to the next one. Yes. Now, it seems very difficult. You can also try yourself depending upon the hint I have given to you. I've given you a hint in this question. Okay. When the angle will be reduced and when the angle will be increased. Taking the hint from this particular problem, I have taken both the possibilities. I want you to try yourself, and for your convenience, answer is already highlighted. Okay. Can you try this? So in our following sessions, I'll be helping you out with this also, but you try first. If you want right now, you can take the screenshot. Take the screenshot, although the notes will be attached in the description by the end of the day. All right, chaliye. Let's move on to the next one. Now, we are going to talk about another model, that is ship model. Ship model, distance of closest approach. Another model in which the relative velocity will have a very beautiful use. Even if we don't use the relative velocity, there will be other approaches. There will be other approaches to solve this particular model, and there will be symmetry approach also. So we will talk about it. Okay. So ship model. First of all, let me tell you the concept. What is the concept here? The concept is there will be two ships. Suppose they are in this direction. There is ship A. There is ship A moving with a speed V0, and there is a ship B, ship A over here, ship B over here. If ship A is moving with V0, ship B is moving perpendicularly to this V0, and the initial separation between them is D0. Initial separation between them is D0, and if you try to understand the separation between them, I'll mention that separation by taking the help of this solid line. So initial separation between them is this. After a while, the B will travel here and A will travel like this. So I will say the separation between them will be somewhat like this. A would have traveled some distance, B also would have traveled some distance. The line joining them will represent the separation. Then now the separation will be like this. Later on, the separation will be like this. The separation will be like this. And finally, their separation will become this. When A has reached the position of B, the B would have reached somewhere here. So these are the lines, white color, blue color, green color, pink color, yellow color. These are the lines which are basically representing the separation between these two ships. They are representing the separation between these two ships. Questions. Question number 1, question number 2. Question number 1 is here in this concept, problem number 1. Question number 1 is determine the time after which the minimum separation, they will never be able to approach each other. They will never be able to meet each other. The reason is they are moving with the same speed. As soon as the A is traveling along this vertical, this line, dotted line, y-axis line, the B is also traveling in the x-axis line. So determine the time after which the minimum separation will be attained. Minimum separation will be attained. That is first problem to us. Question number 2, what is the minimum separation? You have to tell both the things. After what time they will be attaining the minimum separation, and what is the minimum separation? What is the minimum separation between the two ships? Okay. So these are the two things examiner might ask you. There are multiple methods to deal with that. Way 1. Okay. Way 1 of answering both the questions, in fact, way 1 of dealing with it is the maxima and minima. Technique of maxima and minima. Technique of maxima and minima means you have to do dy by dx as 0. Dy by dx as 0. That is dy by dx as 0. Okay. Way 2. Technique 2 of dealing with it. I will say technique 2 of dealing with the ship model is relative motion between them. Relative motion between them, and also a concept and logic is that minimum separation of a point from a line. Minimum separation of a point from a line is always the perpendicular distance. You have learned this property since your childhood. There is a line, there is a point. If I have to, I have to find the minimum separation from this point in space to this line, I'll drop a perpendicular. So I'll stand on any ship, I'll observe the other ship. I'll stand on any one ship, I'll observe the trajectory, I'll observe the journey of the other ship, and then I'll drop the perpendicular. So that perpendicular dropped will give you the minimum distance. So the minimum separation of a point from a line is always the perpendicular distance. And way 3 by symmetry. Way 3 is the easiest, symmetry. But for symmetry method, then definitely the situation should be symmetric. Means both the ships must be moving with the same speed and in this perpendicular direction. If the speed will vary, or if like they are V1 and V2, VA, VB, or if the direction is not, the given as per the given figure, then this method cannot be applied. But generally, we are expecting that if it comes in the exam, it will come with so symmetric situation. In that case, do you observe that initial distance yellow and final distance, initial distance white color and final distance yellow color, they are going to be the same separations. D0 and D0. Similarly, pink colored and green colored are going to be almost similar separation. The blue colored line here, this blue colored line over here, I will say that will be the X minimum. that will be the separation between them by minimum separation between them by symmetry. Okay, the shortest line, the shortest length line is this blue colored line by symmetry. I hope everyone agreed. So technically speaking, can I say if they ask the time after which the minimum separation will be attained, then that will be the time when d0 by 2, when d0 by 2 distance has been traveled and d0 by 2 is further about to travel, about to be traveled. d0 by 2 has already been traveled, d0 by 2 is still remaining. So if I am answering the first question, time t0, required time, then I will say what distance is supposed to be traveled, d0 by 2 distance is supposed to be traveled, and with what speed it is supposed to be traveled with v0, and hence the answer is d0 by 2 v0. Not only that, if they are asking you the x minimum, then you will say by Pythagoras, if this is d0 by 2 traveled, then definitely this is d0 by 2 traveled and this is d0 by 2 remaining. So by Pythagoras, this is d0 by 2, this is d0 by 2. So obviously this is root 2 times d0 by 2. Root 2 times d0 by 2, or you can also say d0 by root 2. d0 by root 2. Let me write it here for you. d0 by root 2. Okay. So these are the ways, like I'll take up one numerical, don't worry, I'll take up a PYQ in which I'll apply all the techniques for you. You will realize that the first technique is lengthiest but most standard technique. That is the lengthy technique, but that is basically the most standard technique, because even if there is no symmetry, even if they are moving in random directions, then that technique is going to help you out. That is going to be helping every time. Okay, just have a look. What I've told you, that this is a ship model. There are two questions. In riverboat problem, last time in riverboat problem, there are two questions. Question number 1, time to cross the river. Question number 2, the drift produced. Similarly, in rain umbrella problem, previously we have discussed today, there are two problems. Question number 1, with the speed of hitting. Question number 2, at what angle you should hold the umbrella in order to protect yourself from the rain. Similarly, in ship model, there are two questions. Question number 1, time after which they will be attaining the minimum separation between them. Question number 2, what will be that minimum separation? So by all three methods, you can answer the same. The first one is the lengthiest but most standard, and the last one is the shortest, directly by the formula, by symmetry. But obviously that is applicable when there is a symmetry in the situation. Okay, so can I take it ahead? Let me take one problem for you. The problem is, two ships are 10 km apart on a line from south to north. Two ships are 10 km apart on a line from south to north. The one farther north, so there are two ships, A and B. A and B here. Okay, and the separation between them is 10 kilometers here, 10 kilometers. The one farther north is moving towards west at 40 km per hour. So which one is in the north? That is moving towards west at 40 km per hour. And the other is moving towards north. This one is moving towards north. The one which is in south, that is moving towards north with the same 40 km per hour. Can you see the symmetry here? All right, symmetry is already there. The distance of closest approach is, suppose this distance is x. It has traveled a distance x here, suppose. Then in the same time, since this ship B is also moving with the speed, the same speed, definitely it would have traveled x only. If this has traveled x, then this would have traveled x. Then the separation from here to here, this separation will be 10 minus x kilometers. But they are moving with the same speed. If they are moving with the same speed, in the same time, they will travel the same distance. So suppose it has traveled a distance x over there. So this will also travel x. So the remaining distance here will be 10 minus x. Now, if I try to join this, if I try to join from here to here, like this to this will give you some separation, some random separation. So this separation y is equal to under root of separation y is equal to under root of Pythagoras theorem, this square plus this square, x square plus 10 minus x ka whole square, x square plus 10 minus x ka whole square. So that is equal to under root of, if you expand it, it will be 2x square, and what else, plus 100 minus 20x, I think 100 minus 20x, you got this. Now this is the situation for you. Okay, this is the separation. Now the point is that for separation to be minimum, your dy by dx must be equal to 0. Let me now shift it over here so that I can write it for you. Okay, now see, for separation y to be minimum, can I say my dy by dx must be equal to 0? Technique of maxima minima, my dy by dx must be equal to 0. This implies d by dx of, can I say directly differentiate the inside term? Because if the term, inside term is minimum, inside term differentiation is 0, then its square root is also going to be 0. So I want to minimize that. In fact, 2x square plus 100 minus 20x, its derivative is 0. So it will be 4x plus 0 minus 20, that will be equal to 0. This implies 4x will be equal to 20, or x will be equal to 5. X will be equal to 5 kilometers. But this is the value of x. This is not y minimum. So y minimum will be y when x is 5. So that will be equal to under root of, in this expression you are supposed to keep the x as 5, 2 into 5 square plus 100 minus 20 into 5. So that will be under root of 5 square is 25, 25 into 2, 50, plus 100 minus 20 into 5 is 100. See, this 100 got cancelled. Root 50 you got. Root 50 means 5 root 2 kilometers. 5 root 2 kilometers, or you can also write it as 10 by root 2 kilometers. 5 root 2 or 10 by root 2. And see, hence the correct answer is already the highlighted answer. So I hope you realize that it is a very lengthy approach. Why it is lengthy? Because we have to assume that it has traveled a distance x, that will also travel a distance x. We will find the final separation in terms of x. Then we will apply the maxima and minima technique, because they are asking you the minimum separation. You have applied the maxima and minima technique, and after getting the value of x, you need to find out the minimum separation. So again, another step is here. Maximum students do this mistake also. They stop at 5, and I think right now they are not giving you any option, but examiner is so smart. If they are giving you this problem, they will also give one of the options as 5, probably option A, for triggering the students to do the common mistake. But I hope that is understood. X was not the separation was y, that was something in terms of x by using the Pythagoras theorem. Is that clear? Now, okay, so that is the situation. Now we are interested in doing the same problem by another approach. That is directly symmetry method. Can I do that by symmetry here only? So this is way 1. This is way 1, the lengthiest. Way 2, the shortest, the easiest, by symmetry. Okay, by symmetry, I will say, I hope you realize that at half, 50% of the journey, x minimum is attained. X minimum is attained exactly after traveling half of the distance. Exactly after traveling half of initial separation. So, can I say the x minimum will be given by the remaining half will be available. So, perpendicular will also be half and base will also be remaining half, and you can apply the Pythagoras. So, that will be root 2 times d naught by 2, or you can also write it as d naught by root 2. So, that is equal to 10 by root 2. 10 by root 2. See, that's the final answer. You can directly use the symmetry. which I have told you. What about the remaining method, sir? The remaining method means, standing on one, looking at the other, standing on the other, looking at the one. I'll also give you that idea. Have a look. If you want, you can take the screenshot as well. Have a look. The lengthiest method is also in front of you and shortest method is also in front of you. See, this is most time taking. Okay, but that is the most general and this is the shortest way. Shortest and quickest. You don't have to think much even about the logic, but the only issue with this is that it can be applied only if the situation is symmetric. And I am saying that I am expecting this type of symmetric situation. All right, now you can take the screenshot. All right. So now I hope we are done with the rain umbrella model and we are even done with the ship model. Now we will discuss few other models which are based on relative motion. Relative motion, kinematics only, few other models. Means not river boat, not rain umbrella, not ship model, but some other things. So the first is in front of you. Two particles A and B are connected by a light rigid rod. What is the significance of rigid rod here? Rigid rod means allows no deformation. No deformation. That is the property I'll write. The separation between any 2 points. Separation between any 2 points along the rod. Separation between any 2 points along the rod will remain same. Will always remain same. Or in other words, you can also say velocity of any point along the rod. Velocity of any point of the rod along the rod, it is going to be constant. And if it constant or same, if any 2 points you consider and they must be having the same velocity along the rod. If any 2 points you consider and if they must be having the same velocity along the rod, which means the relative velocity VA minus VB will be 0. Because if the individual velocities are same along the rod, so their relative velocity will be 0 along the rod. All right. So here you can say or relative velocity of V relative of any 2 points. Any 2 points along the rod. Along the rod, that is going to be 0. That is going to be 0. So today onwards, you will remember it this way, that the meaning of rigid, the rigid body dynamics, rigid bodies dealing majorly come in our later chapters in center of mass, rotational motion and other topics. But right now, what is the significance of dealing with rigid body is that number one, we will say that since it doesn't allow any deformation along the body, along the rod here in this case. So in general, along the body, the separation between 2 points will never change, which means along the body, all the points will be moving with the same velocity. If they are moving with the same velocity, their relative velocity along the body or along the rod in this case must be equal to 0. So these are the 3 different properties I have listed in front of you. All right, these 3 different languages can be used to understand it better. Okay, now question, let's come back to the question. The question is 2 particles A and B connected by a rigid rod AB. The rod slides along the perpendicular rail as shown. A and B are the rails and this is the rod that slides. Velocity of A to the left, is 10 meter per second. What is the velocity of B when alpha is 60 degrees? So see, if this is the this is the velocity of A, they are giving this as VA. So I can resolve it here. That is VA cos alpha along the rod. And this will be VA sin alpha along the rod. This perpendicular to the rod. This is VA cos alpha along the rod and perpendicular to the rod. This is VA sin alpha. Why this is cos? Because the angle is made with this. Fine. Now similarly, if you try to observe this, you will say if this is alpha, let's extend it here. This is basically VB. Okay. And if you extend it like this is alpha, which is 60 degrees. Let me write this here, that alpha is equal to 60 degrees given. So this is cos 60 degrees and this will be sin 60 degrees. Then naturally this angle will be 90 minus 60 is equal to 30 degrees. If this angle is 30 degrees, then here also it is 30 degrees, vertically opposite angle. Then you will say this component will be VB cos 30 degrees and this component perpendicular will be VB sin 30 degrees. VB cos 30 degrees, VB sin 30 degrees. That's what you got. And now the property is that along the rod, these must be same. Along the rod, these velocities must be same. Along the rod, the velocity components must be same. Along the rod. This is perpendicular to the rod, There is no restriction on that. Along the rod, there is a restriction. So here, along the rod, you will say VA component must be equal to VB component. Okay, this implies VA component is VA cos 60 degrees, that will be VB cos 30 degrees. All right, VA value is I think 10 meter per second they are giving. See the data in the question, 10 meter per second. 10 cos 60 degrees is 1 by 2. VB you want to find, cos 30 degrees is root 3 by 2. You see this 2 and 2 in the like half got cancelled. So what you got is VB is equal to 10 by root 3. Root 3 value is 1.732, I think everyone knows. So if it would have been 2, suppose it is 10 by 2. If it would have been 10 by 2, the answer would be 5. But since denominator is slightly less than 2, the overall answer will be slightly greater than 5. Slightly greater than 5. If you see all 4 options, it is 5.8. 5.8 meter per second. That is option C. That is the correct option. I hope this problem model is also clear to us. So there will be a lot of questions, a lot of problem models of relative velocity. I hope you understood the basic discussion of relative velocity. The idea of relative velocity and the equivalent velocity is clear to you. We are also comfortable with riverboat and rain umbrella problem along with the ship model also, and another model in front of you in which we combined the relative velocity logic even to the rigid body. Okay, previously we have talked about the particles or the individual bodies, but right now we have also taken up the model in which we have talked about the rigid body. All right. So with all this, I stop here with the discussion of relative velocity. Again, I'm saying there are a lot of variety of models. We can't assume that, doing this will 100% put a full stop in front of the topic. No, it's not like that. These discussions are meant to, strengthen your fundamentals so that at least you can start dealing with such models. But there are a lot of models in the full-fledged course only. You can expect that you will put 100% completion you can expect in the full-fledged course only. All right. So all the best. That's all from my side today. And take care of your health. Find a good time to revise also. Stay smiling. Hope to see you soon. All the best. Bye-bye.